We are starting on page 180, titled Getting Started, and it is Let It Steep. All right, so we're going to start here. This is Module 2, Topic 1, Lesson 2. On page 180, we're going to go through Getting Started, Activity 1 and Activity 2. This problem, though, this is talking about how we have signs on the road that warn cyclists to warn them how steep a road might get so that they can avoid, being in an accident. So what we're going to do is we're going to examine the triangles that we have here. We have 4. Number 1, it says for each triangle, write a ratio that represents the relationship. Let's go ahead and put, we have figure A, B, C, and D. Let's just write that for now. Let's just put I'll abbreviate figure A, figure B. We'll space it out for C and D because we're going to need some space here. All right. Now, we know that in this case, we're talking about how steep something is. This deals with the constant proportionality, right? K is equal to Y over X, which is our output over our input. But also think about this in terms of axis, right? The y-axis, that is, right, if I draw quadrant 1, the y-axis is here, x-axis is here. So that's how much we're moving vertical compared to horizontal. We're going to do that here with these varying sides of the right triangle. Let's start with figure A. We're going to start with this side here, which is 10. And coincidentally, the horizontal line, or you can think of it as the x-axis, is also 10. So this is a ratio, 10 over 10. Okay, we'll come back to this. Let's go to figure B. Figure B is 15 over 4. Figure C is 15 over 15. And the last one, figure D, is 12 out of 3. Now, we're setting up these ratios so that we can kind of compare which one is the steepest or which one is the least steep, or put them in order from least to greatest. And visually you can kind of tell, like maybe it's between one of these two triangles here. But how we can definitively determine this is we're going to write it as a unit rate. What that means is either the numerator or denominator is 1. So pretty much what we're going to do is we're just going to divide them out. So let's start with figure A. Instead of writing it in this space, I'm just going to write it next to the ratio. 10 divided by 10 is 1. I'm going to skip to figure C. 15 divided by 15 is also 1. And figure D, we'll have 12 divided by 3, which is 4. Okay, let's go back to figure B. Now, for this, we can simplify this. I'm going to set this up as a division algorithm. 15 divided by 4. 4 cannot go into 1, but it can go into 15. It can go into it. It looks like, I think, 3 times. All right, 4 times 3 is 12. We'll subtract, not a 0. It is a remainder of 3. Let's extend our division symbol. Put decimals. I'll put a couple of zeros here. Let's bring down, it looks like it will go to the hundreds place. 4 can go into 30, right? You can skip count by 4. 4, 8, 12. It will go into it 7 times. 4 times 7 is 28. I'm going to have to go into this extra space here. 30 minus 28 is 2. And looks like we can finish this up by bringing down the 0. 4 can go into 20 exactly 5 times. So figure B, although we had to do some work here, is 3 and 75 hundredths, 3.75. All right. Now we've already done number 1 and number 2. Number 3, how can you use these rates to compare the steepness of the triangles? So which one is the biggest number if you're looking at these last spaces here? Okay, the one that's the biggest number is figure D. Figure D is the steepest. I'll put fig D is the steepest triangle. Okay, what else can we can put them in order from least and greatest, but I'll just compare figure A and figure C. Figure A and C. Right, when we simplify, they're both 1, so they have the same steepness. So figure A and C, have the same steepness. There's a word that we're going to look at later that actually represents steepness that we'll be referring more, but let's leave it like that. Okay. And if you look at figure A and figure C, I mean, like, they look like they're about the same steepness here. If I take this line and move it, yeah, it's pretty much matched right on top of it. Okay. If I take this line, maybe this is slightly steeper, or sorry, figure D is supposed to be steeper than this. Let's take that. And it's kind of hard to see. I mean, it looks like it's just about the same, but they're going to be close because 3.75 is really close to 4. Okay, but figure D is the steepest. All right, let's go to activity 1. Constant proportionality as rate of change. And for this, we're going to be completing a table as well as graphing, so using our resources there. But let's look at the context here in the box. It says, on Monday, Jack and Jill walked from their home up a hill to get to the bus stop, and they walked at a specific rate. It was 4 yards every 3 seconds. Okay, right, so 4 yardsticks every 3 seconds. That seems pretty fast. Number 1, does this situation represent a proportional relationship? This is yes. Right, we are going to have a, we'll just say that it has a constant speed. Right, typically when you talk about speed or rate, you talk about miles per hour, but since we're walking, we're looking at yards per second. The constant proportionality, we'll put K. Constant proportionality in this case, or we talked about it's the output versus the input, the dependent variable over the independent variable. Since it's 4 yards every 3 seconds, this will be 4/3. Okay, so keep in mind, right, right, we have distance as being dependent and time being independent. So let's go and write that for number 2. It says write an equation to represent the distance, D. Jack and Jill walked over time, T. Now, typically for an equation, we would write y equal to kx. Instead of y and x, we have other variables here. Our k value we know is 4/3. Right, 4 yards. And we know that here, this is our output or a dependent variable. The output here is distance. And here, this is our input. And our input will be time. Right? The distance will depend on how long we're walking. Or how long we're walking affects the distance that we travel. Okay. And we can also see that here, what is x and y. Look at your axes here. We have distance for the y-axis, that is output, and time for the x-axis, that is input. Anyways, we have almost a completed table here. It says complete the table, then graph the points, finally draw a line. It's going to be a straight line to represent the relationship between the time Jack and Jill walked and their distance from home. Let's start with the first one. We know that we always start at the origin, so this is always going to be 0, 0. So let's graph this point here. Now, if you look at your axes here, we have in terms of 1 for every 2 grid marks, but right here, this is a half. So let's keep that in mind, right? A half and a half, make a whole, right? This would be like 1.5 and then 2. All right, anyways, I'm gonna erase this. We don't need this. All right, let's look at in terms of 1 second. Now, if you were to plug in 1 here, let's say for 1 second, distance is equal to 4/3. And instead of t is seconds, we're going to say 1 second. This is just saying what is 4/3 times 1? 4/3 times 1 is 4/3. So let's write that in. I mean, it's kind of hard to graph 4/3, so let's put this as a mixed number. This is 3 can go into 4 once with a remainder of 1, and we divided by 3. So we're going to have to really try to approximate this here. So let's graph this. The second row, it is 1 second. So that is 1 to the right, like that. And 1 1/3 up. So it's got to be somewhere right here. Okay, so just do the best you can to graph that. Let's go with 3 seconds. So D is equal to 4/3 times 3. We talked about this. We got to put this over 1. Let's multiply this out. 4 times 3 is 12. 3 times 1 is 3. and this is 4. All right, so that makes sense, right? This is actually from our context. 3 seconds, we walked 4 yards. That's in that boxed area for the context. Let's graph that. That is 3 to the right and 4 up. 3 right, 4 up. So 3 right, 1, 2, 3, 4 up. 1, 2, 3, 4. So I have to be careful here. I have to skip every 2 grid marks here. But let's go and put a point right there. Now, although I'm drawing these arcs, I just want to make sure that this is kind of clean, so I'm going to erase those arcs there. All right, next one. Now, this now we're given the distance. We're saying the distance is 8. Now, let's keep this in mind. We have 4/3, right? 4 yards every 3 seconds, but we're saying for this one we went 8 yards. We got to figure out how many seconds it takes to get there. You could cross multiply because we have a fraction equal to a fraction. Let's set this up. 4 times x is 4x. 3 times 8 is 24. And then from here, you could divide both sides by 4. What is 24 divided by 4? That is 6. There's other ways you can find that. You can actually just compare, right? 4 times 2 is 8. So 3 times 2 is 6. All right, but let's go to 8 or 6, 8. So 6 to the right, 8 up. Just got to be careful. Let's graph it. I think that's the correct point. All right. All right, let's do the next one, which is we're going to set up a proportion for this. 7.5 seconds. I mean, 7.5 seconds. I don't know why they're giving that to us, but let's deal with it still. Okay. So distance is equal to 4/3. The time here is 0.75. We'll put this over 1. Okay, so let's multiply fractions. So I'm going to multiply horizontally. So let's do 4 times 7.5. I'll put that over here. All right, 5 times 4 is 20. Put 0 here, carry the 2. 4 times 7 is 28, plus 2 is 30. So this is 300, but keep in mind our decimal point here is 1 space. So we have to move it 1 space here. So it's actually 30.0, but this is just 30. And then 3 times 1 is just 3. All right, so our final answer is just whatever 30 divided by 3 is. That is 10. Okay. All right, let's go to 7.5, 10. 7.5, that's right here. I normally won't make a grid mark here, but I'll just do it for the purpose of the video. And let's go up 10. Looks like it's going to be right here, if I compare that correctly. And hopefully you can see right from this, we have a straight line here. Let's go to 9 seconds. Right, distance is equal to 4/3 times 9. Let's put over 1. This is 36. Sorry if I'm going a little fast. 36 divided by 3 is, right, 3 can go into 3 once, and it's a 6 twice, so it is 12. All right, so let's graph that. 9, 12. So almost at the edge of the graph, and then up 12 right here. All right, as best you can, try to draw a straight line or maybe connect the dots. But if I were to draw a straight line here, it's a little bit easier for me. Yeah, we worked this out exactly correct. We have a straight line. This is a proportional relationship. It's of the form y equal to kx. It's a straight line through the origin. Looks good. All right, we're gonna work on this context on the next page. So let's go and flip over to page 182 to end activity 1. Okay. Number 4. What is the unit rate? So we talked about the unit rate here is, right, we have to divide by 1. So we're going to put that the unit rate, right, it is, right, we know that it is 4/3, but this is in terms of 1 second. So what does this mean? So the unit is 4/3, so this means it's 4/3, or sorry, 4/3 yards every second. So we're gonna say per second. Right? We talked about earlier, we converted this to mixed number. This is also 1 and 1/3, so slightly over a yard every second. So every second over a yard. Okay, a little over 3 feet. All right, we're gonna skip number 5. But a key thing here, right before number 6, we have a key vocabulary term, the rate of change. Rate of change, you learn about it in pre-algebra, but you'll learn more about this continuing in Algebra 1, so at 9th grade level math. It says the rate of change for a situation describes the amount that the dependent variable, underline that, changes compared to the amount that the independent variable changes. So let's actually write that. So we know that k is equal to y over x, but it is the output over the input. But we just talked about it here. This means constant proportionality is exactly the same as the rate of change. It is the dependent variable, I'll just put DEP, over the independent variable. All right. Okay. So for number 6, consider the situation, identify the dependent variable and independent variable. We're going to say that I'm not going to put a first sentence, but we'll just say independent variable. This was time in seconds. And the dependent variable, this was distance, right? The dependent variable, distance depended on time. This is distance in terms of yards. Okay. Identify the rate of change. It's exactly the same. It's 4 yards, we'll abbreviate, every 3 seconds, SEC. And we're going to use that to compare number 7. Consider the 3 things here: the rate of change, constant proportionality, and the unit rate for this situation. They are all the same. Let's just put all the same. They mean the same exact thing. So if you ever hear these words, they're synonymous. All the same, all are 4/3. Okay, we're going to skip number 8. We're going to move on to activity 2 on page 183. Okay, so let's get to that. All right, now we have a new word here, but you've already heard of this word. We have slope of a line. The slope, when we talk about the slope, this means the steepness of a line. So for this, it says you wrote the equation d equal to 4/3 times t to represent the distance d that Jack and Jill walked over t. We're going to look at 3 scenarios here. And this is also going to talk about, it says for us to use patty paper. We're just going to do the best that we can to draw. The graph shown represents this relationship. Let's analyze 3 different moments in time. So we're going to analyze at 1 second, 3 seconds, and 6 seconds. And these are things that we already did here, right? 1 second, 3 seconds, 6 seconds. So let's try to remember this. It was 1 1/3, 4, and 8. So 1 1/3, 4, and 8. And we have that graphed here because this second one here is at a height of 4. This one has a height of 8, and this one has a height of 1 1/3. Yeah, I'll keep that there. This says trace a triangle on a piece of patty paper and label the horizontal and vertical sides of the triangle with their respective lengths. Yeah, I mean, we could do that, but I'm going to trace this here because it's a little bit easier for me because I'm using the device. But I'd like for you to do this. I'd like for you to draw a triangle. Oops. And it's not perfect. Try to draw this triangle. It's the same exact, it's similar. Right here. And then we're going to draw that triangle again. So this is at the point, it's 2 comma, looks like it's 2 2/3. Okay. I'm going to draw the same thing again. All right. Now it looks like to get here, which is 3 seconds, it looks like it's a total from the origin, 3 of these triangles. So 3 seconds, 3 triangles it took to get here. Okay. So this we're not actually writing out, but let's go to number 2. It says draw right triangles to model t equal to 3, which is what we just did. But let's also do the same thing to get all the way to t equal to 6. Let's draw a straight line here. All right, but we're going to draw the same thing. So it looks like we go 1, 2, 3, right? 1, 2, 3, 4 up. Let's just continue going that path, going 3 right, 4 up. So 1, 2, 3, 1, 2, 3, 4. And let's just continue it. I don't know why my lines aren't straight. Okay. We get the idea there. We kind of got like the shark teeth looking thing. All right. So for this, they were all 3 to the right and 4 up. Okay. So it says then trace the triangle on a separate piece of pattern paper. We didn't do that. We just drew it on here. Label the horizontal and vertical sides of the right triangle. We just put it here, 3 and 4. Right, and that makes sense, right? 3 right, parts of time for every 4 parts of distance. All right. And it says determine the steepness of each triangle. Now, each triangle here, the first one when t was equal to 1, it is... Oh, sorry, when t was equal to 1, whoops, let me erase this. The ratio is 4/3. Okay, let's go to the other ones. When t was equal to 3. All right, when t was equal to 3, the ratio is also 4/3. Right, because we're using that same pattern here. And then last one, same thing when t was equal to 6. We're going to put, I'll just put 4/3 here. Sorry, got Miss Moore in the background. All right, let's go to the last part of activity 2. Let's go and end this. Number 4, what is the relationship among the three big triangles here? Oh, I didn't draw the big, oh, we did draw big triangles here. We have this small one, this one compared to this line, and we have this one as well. We're just going to say that they're all the same shape, which means that they are all triangles are similar. Okay. All right. We're actually going to skip 5 and 6. We're going to leave it there, as well as, sorry, as also number 7. Okay. All right, so we're going to end it there. If you're finished a little bit early, you're working on Mathia, but thank you.